What is NTP? How the internet agrees on the time. Time is a stack, not a number. Watch a clock, left alone it drifts. At layers 0 and 1, we saw the crystal is already slightly wrong. Counting your own ticks, you always drift. So a machine that wants the right time has to keep asking a better clock and correcting itself. You don't measure absolute time, you ask for it over the network on UDP. This is NTP, defined by RFC 5905 NTP version 4, spoken over UDP port 123. One request, one reply, 4 timestamps, 2 answers. T1. The client notes the moment its request leaves. A cyan packet starts crossing the network, and that takes time. T2. The server stamps the moment the question arrives, measured on its own clock. After a short processing gap, the server packs T1, T2, and T3 into a reply. T3 is the moment that reply leaves. T4. The reply lands and the client stamps the moment of arrival. 4 numbers measured by 2 different clocks, that is the entire wire protocol. Hold the whole picture. The exchange traces a zigzag, a Z, from T1 down to T4. Redraw it from memory and you have NTP. Combine the 4 and you get the offset, theta, how far the client's clock is from the server's. Add it and you're aligned. The averaging across both directions is what makes the next part work. The other answer is the round-trip delay. Total time the client waited, minus the server's own thinking time. What's left is the time actually spent crossing the network, both ways. You measure delay so you can cancel the network. Assume each direction took half the round trip, and the latency drops out of the offset. But that is an assumption. Asymmetric routes bias the offset by half the difference, the reason NTP tops out at milliseconds on the open internet. Once you know the offset, you don't yank the clock. By default, you SLEW, run it a touch fast or slow until it catches up. Applications never see a jump, and time always moves forward. You only step a single jump when you're so far off. SLEWing would take forever. And you avoid stepping the wall clock backwards because software assumes time moves forward, the monotonic clock from layer 2. NTP doesn't ask once. It pulls on a schedule, tens of seconds out to about 17 minutes, sampling repeatedly, filtering bad round trips, and backing off as its estimate settles. Crony, NTPD, and systemd-timesyncd all do this. One question we quietly skipped: who is this server asking? It has a better clock because it's synced to an even better one, all the way up to an atomic reference. That chain of trust is the stratum hierarchy, the whole next playlist. Measure how wrong you are, cancel the network, nudge, don't jump. 4 timestamps, 2 answers, that is NTP. Time is a stack, not a number. Next, where the trustworthy clock comes from, stratum.